This video is going to talk about the product rule and the quotient rule for derivatives. So if we have a function f of x that is created by having two different functions multiplied together, let's call them u times v. So maybe we have a function f of x equals x plus 5 times sine of x, two different functions multiplied together. We need a way to find the derivative for this function. This is especially helpful in this case if one of these functions is not a polynomial and we couldn't multiply these out. But for the purposes of this video, we will talk about how to use this with polynomials only. So the product rule for derivatives is to take the derivative of the first function, so we'll call that u prime, times the second function, plus the first function times the derivative of the second. Notice you can't take just the derivative of the first function and multiply it by the derivative of the second function. You have to use product rule here. So to give you an example of how we could use this with an actual function, let's say that f of x equals 5x squared minus x plus 1 times x cubed minus 1. Okay. So we're going to let 5x squared minus x plus 1 be our u function and x cubed minus 1 be our v function. So to find our derivative, f prime of x is going to equal the derivative of this first function. So the derivative of 5x squared is 10x. Derivative of negative x is negative 1, and the derivative of 1 is 0. And so we were going to multiply the derivative of u times b, so times x cubed minus 1, plus the derivative of u, 5x squared minus x plus 1, times the derivative of v. So in this case we would have 3x squared. So I have b prime, u, v, and uv prime. So u prime times v plus u times v prime. So then we can just clean this up, do some multiplication. 10x times x cubed is 10x to the fourth. 10x minus 1 is minus 10x. Then minus x cubed plus 1 plus 15x to the fourth minus 3x cubed plus 1. So then we have that f prime of x will equal 25x to the fourth minus 4x cubed plus 3x squared minus 10x plus 1. So we can use this derivative to find the slope of the tangent line, to write the equation of the tangent line. Everything else that we would use a derivative for, we can use this expression with, because this is the derivative of our original function. The next rule that we want to talk about is the quotient rule. So this time, instead of having f of x be u times v, we have f of x equals u divided by v, so long as v is not equal to 0, because then we would have an undefined function at that value. So the derivative of this function using the quotient rule is f prime of x equals u prime times v minus u times v prime all over v squared. So you'll notice this is similar to the product rule in how the numerator looks. I'll put the product rule up here so you can kind of compare. So the product rule is u prime times v plus u times v prime. The quotient rule is u prime times v minus u times v prime. And then you have to divide by v squared. So at a later point, we'll be able to show how we got this quotient rule from the product rule. But for right now, we're just going to work with this formula until we have further information to prove it. So to give you an example with the quotient rule, let's look at the function f of x equals x squared plus 1 over 2x minus 3. So again, we're going to identify our two functions. We have u and v for our different functions. So to use our quotient rule, f prime of x is going to equal the derivative of u, so in this case 2x, times v, 2x minus 3, minus u, which is x squared plus 1, times the derivative of v, which is just going to be 2. And that is all over the original v function, 2x minus 3 squared. So this looks very messy, but it's easier than trying to work with the product rule with x squared plus 1 times quantity 2x minus 3 to the negative 1 power. Plus, if you don't know how to take the derivative of a polynomial raised to a power, you're not able to use the product rule in this type of situation. So we're going to continue cleaning this up. All we need to do is simplify our numerator. We don't need to expand our denominator. So I have f prime of x is equal to 4x squared minus 6x minus x squared times 2 gives me 2x squared. 1 times 2 gives me 2, but I also have to distribute this negative, so I have negative 2. All over 2x minus 3 squared. And so to combine like terms, f prime of x equals 2x squared minus 6x minus 2 all over 2x minus 3 quantity squared. It's always a good idea to check and see if you can factor your numerator and possibly have something cancel out in the denominator. In this case, all we could do is factor out a GCF of 2, and the remaining polynomial would not factor to cancel with anything in the denominator. So we're just going to leave this as our final answer. So this gives you some examples and an overview of the product rule and the quotient rule and how you can use them to find the derivative.